All right, today we're going to talk about a piece of tech that completely changed the game for anyone who builds software: Docker. If you're a developer, you've definitely heard of it. But even if you're just a little tech curious, you're in exactly the right place. We are going to break down what it is, why it matters so much, and we're going to start right from square one. Let's do this. Okay, let me paint you a picture, one that is way too familiar for anyone who's ever tried to code something. You've just spent weeks, maybe months, building this incredible new application on your laptop. It's running perfectly, you feel like a genius. So you hand it over to your colleague or you try to push it up to a server and damn, it completely falls apart, nothing works. If you are nodding your head right now, you know exactly what I'm talking about. That right there is the infamous "it works on my machine" problem. It's this universal headache that's caused by all these tiny, invisible differences between one computer and another. And this is the exact specific problem that Docker was invented to solve, once and for all.
So, here's our game plan. First, we're going to really unpack that universal problem. Then, we'll use a fantastic real-world analogy to help it all make sense. After that, we'll stack up containers against something you might have heard of: virtual machines. We'll look at the key parts of the Docker ecosystem, see how it's used every day, and then we'll finish up with where you can go from here.
So let's be really clear about this. This "works on my machine" thing, it's not just a small frustration. It is a massive roadblock in software development that burns up countless hours of people's lives trying to figure out what went wrong. And here's the real kicker. An application is never just about the code you wrote. No, it depends on a whole world of other things to actually run. Specific versions of libraries, different system tools, particular settings, you get the idea. So if your laptop is using version 3.8 of some critical library, but the server has version 3.9, well, that tiny little difference can be enough to bring the whole thing crashing down. Now, to really get how Docker fixes this, we're actually going to take a little detour away from software completely. We're going to look at the world of physical cargo, because the solution to our digital problem was inspired by a massive revolution in global trade that happened decades ago. You see, before the 1960s, loading a cargo ship was absolute chaos. You had all these goods in different shapes and sizes: sacks of coffee, barrels of wine, heavy machinery, all being loaded one by hand. It was incredibly slow, it was super expensive, and stuff got broken all the time. And then, someone had a genius idea: the standardized shipping container. All of a sudden, it didn't matter what was inside. Every single box was the same size. That meant any crane on any ship, any train, or any truck anywhere in the world could move it. It created this predictive, efficient, universal system. And that, right there, is exactly what Docker does for software. A Docker container is the shipping container for your code. It bundles up your application and all of its dependencies, every library, every setting, absolutely everything it needs, into one single standard box. And just like that metal box, this software container can run on any computer that has Docker installed. Your laptop, your friend's laptop, the cloud server, it doesn't matter anymore. It just works.
Now, at this point, you might be thinking, hang on a second, haven't we been doing something like this for years with virtual machines? And you're right, but they're not the same thing. Containers and VMs are both about isolation, but they go about it in totally different ways. Let's break it down. Think of a virtual machine, or a VM, as a complete computer, but in software. It basically takes one powerful physical server and slices it up into several smaller, independent virtual computers. And the key thing here is that each of those VMs has to run its own entire operating system, its own kernel, its own files, the whole shebang. Now, a container is much smarter about this. Instead of pretending to be a whole new computer, it virtualizes the operating system itself. What does that mean? It means all the containers running on one machine actually share the underlying operating system kernel of that machine. They're just neatly isolated processes, which is an absolute game changer when it comes to efficiency. This makes the difference totally clear. A VM is a heavyweight. We're talking tens of gigabytes in size because it's lugging around a full operating system. It can take minutes just to start up. So think of a VM like a standalone house. It has its own foundation, its own plumbing, its own electrical, everything. A container, on the other hand, is incredibly lightweight. We're talking megabytes, not gigabytes, and it starts up in seconds. The perfect analogy is apartments in a building. They all share the same core infrastructure, the foundation, the main waterline, but each one is its own secure, isolated unit. Okay, so we get the what, but what about the how? How does all this actually work when you sit down at your keyboard? Let's walk through the key pieces of the Docker platform that make it all happen.
Well, it all starts with a blueprint. In the Docker world, we call this an image. The best way to think about it is like a recipe for a cake. It's a simple, read-only text file that lists every single ingredient and every step you need to create your application. It's the plan, but it's not the cake itself.
So if the image is the recipe, what's the container? Well, that's the actual cake. It's what you get when you tell Docker to run that recipe. This living, breathing, running version of your application, that's the container. And you can create as many identical cakes or containers from that one recipe as you want. So who's the chef in the kitchen? Who's taking that recipe and actually baking the cake? That's the powerhouse working behind the scenes, the Docker engine. It's the core technology that does all the heavy lifting. It reads your image, builds it, and runs it as a container. It's the factory and the crane, all in one.
But here's where it gets even better. You almost never have to write these recipes from scratch. Let's say you need a database or a web server. You just go to Docker Hub. Think of it like a giant app store, but for these blueprints. It's a massive public library where companies and the community share thousands of pre-built, ready-to-use images for just about any software you can think of.
All right, enough theory. How are people actually using this stuff in the real world every single day? How does it change things for actual developers and companies? Oh, the benefits are massive. For starters, development teams finally get consistent environments, which kills that works on my machine problem for good. In your build pipelines, you can create an image one time and know with absolute certainty that it will run exactly the same in testing, staging, and production. Because containers start so fast, you can spin up new copies in seconds to handle a sudden rush of users. And it's the perfect technology for building microservices, letting you run lots of small, independent services on the same machine without them tripping over each other.
So we've gone through the what and the how, but I want to end on the most important part, the why. Why should you, personally, care about this for your career? To put it bluntly, Docker isn't just some cool tool. It is the industry standard. It created the container format that pretty much everyone has adopted. It's a fundamental building block of the entire modern, cloud-native world. Huge technologies like Kubernetes, which manages containers at an unbelievable scale, are built right on top of the foundation that Docker laid. Knowing Docker is no longer a nice-to-have on your resume. For most tech jobs today, it's a flat-out requirement.
So if you remember nothing else from our time today, just remember these three things. 1, Docker packages up your app and everything it needs into a single unit called a container. 2, that container will run exactly the same, no matter where you put it, your laptop, a server, the cloud. And 3, it's incredibly light and fast, which makes it way more efficient than old-school virtual machines.
So we've covered the big ideas, the whole revolution that Docker kicked off. The next logical step, really, is to get your hands dirty, because the best way to understand this is to actually do it. So the only real question left is, are you ready to build your first container? Thanks for tuning in.